All right, welcome to the deep dive. Today, we're going to be going deep on the history of the Unix operating system. You flagged the Wikipedia article on this topic, and as always, our goal is to kind of like cut through the noise and give you like the core insight, the twists and turns, right, in this epic tech saga.
Yeah, you want that deep understanding without like having to wade through all the details, right?
Exactly.
So yeah, we're going to kind of like trace Unix's journey from its humble beginnings all the way through its, many transformations and what's its lasting impact on our digital world today.
So let's jump right in. The Unix story, it really starts in the 1960s with this thing called the Multics project, right?
The Multics project.
It was like this collaboration between Bell Labs, MIT,
Oh, wow.
and General Electric.
Okay.
And like their goal, right, was to create this like sophisticated time-sharing system on the GE 645 mainframe.
Yeah.
So what was like the fundamental idea behind Multics? Like what were they trying to achieve?
So the interesting thing about Multics is that they were trying to do this thing called a single level store.
Okay.
Which is kind of like a precursor to virtual memory systems that we have today. But basically the idea was to kind of abstract away the traditional file system. So programs would interact with data as if it was already in memory. And the system would kind of handle all the underlying like loading and saving using like virtual memory.
Okay, so that was the fundamental idea.
Yeah.
And so what went wrong? Why didn't Multics just take over the world? Like it seemed like a good idea.
Yeah. Well, Multics kind of became a victim of its own ambition, I guess.
Okay.
It became so big and so complex. It was like facing these huge delays. The team at Bell Labs was getting really frustrated because it wasn't delivering a working system quickly.
Okay, and that frustration led to Bell Labs kind of pulling out of the Multics project.
Right.
And with them went some of these key researchers, Ken Thompson, Dennis Ritchie, Doug McElroy, Joe Asana. These names are going to keep coming up, right?
Yeah.
So what was their thinking after the Multics experience?
So it's interesting. Their time with Multics, while it wasn't like a smashing success, it did kind of clarify what they didn't want in an operating system.
Okay.
In 1979, Rishi actually described their goal as preserving not just a good environment in which to do programming, but a system around which a fellowship could form.
Okay.
So they wanted to rebuild, they wanted to redo the work, but on a much smaller scale.
Okay.
And they also wanted to foster that close communication and collaboration among the users of these time-shared machines.
Right. So it seems like Ken Thompson was kind of like the driving force behind like moving away from Multics, right?
Yeah.
Like he saw the problems and he had this like vision for a new system. What were like his core principles for this new system that he had in mind?
Yeah, I think that's right. Thompson really appreciated the hierarchical file system that Multics had,
Okay.
but he fundamentally disagreed with this whole idea of a single level store. So he was like, program code and data, even though they're both in memory, they're used so differently.
Okay.
So he felt like treating them the same is just inefficient. So his key change was to keep that hierarchical file system, but ditch the single level store.
Okay.
And that meant like programmers would kind of have to, manage data loading and saving themselves.
Got it. And so like I heard that Thompson actually started experimenting with these ideas by simulating his proposed system within Multics itself.
Yeah, that's right. He was basically prototyping, right?
Okay.
He was trying to evaluate like how the paging performance of his new system would behave.
Right.
And these simulations, they looked really promising. So he actually started to code the new system for the GE 645. He even developed like a custom assembler. But Bell Labs was kind of like phasing out the GE 645 at this time.
Right.
So this work was kind of discontinued.
Okay. And so despite Thompson like repeatedly asking for a smaller machine to kind of like continue these experiments, management didn't really give it to him right away.
Not right away, no.
So it almost feels like Unix was born out of this blend of like technical vision and like a little bit of organizational resistance, right?
Yeah, I think that's right. Sometimes innovation arises from necessity. Or in this case, the lack of resources.
Yeah.
But Thompson was persistent. He developed this video game. It was called Space Travel, right?
Okay.
On a smaller GE 635 machine that was running this GEOS operating system.
Okay, Space Travel. I read that this was like a really expensive game to play.
Yeah, so running a single game of Space Travel could cost you $75 in CPU time.
Wow.
Which is like, a significant amount even for back then. And so, this costly hobby inadvertently became a catalyst because he discovered this unused PDP-7 machine.
Okay.
I was over in the Visual and Acoustics Research Department, and he was like, okay, you know what I'm going to do? I'm going to rewrite space travel for this PDP-7.
So this is just like finding opportunity where you least expect it, right?
Exactly.
So what was the process like initially of developing on the PDP-7? Like, I think I read that it was like this really manual and kind of inefficient process, right?
Yeah, it was really cumbersome. Like, he would write the code on the GE 635. He would then compile it for the PDP-7, and then he had to physically transfer that resulting binary code using paper tape.
Wow.
And it was this very tediousness that motivated him to start developing his new operating system directly on the PDP-7. And he had some crucial early contributions from Dennis Ritchie and Red Canaday.
Okay, so what were the first key components of the system on the PDP-7?
So they started by implementing that hierarchical file system that Thomson had envisioned, right? And soon after, they were able to actually execute programs that were stored within that file system.
Oh, wow.
And then came the essential utilities, so commands for copying files, deleting files, printing files, editing files, and of course a command line interpreter to allow users to interact with the system.
Okay, and then Dennis Ritchie came up with this really elegant concept of a device file.
Yeah, this was a stroke of genius, I think.
Okay.
So Ritchie basically conceived of treating hardware devices as files within the file system.
Okay.
Now, these weren't like typical files holding data. These were special files that when you access them, it would trigger input-output operations on the underlying hardware. So it kind of abstracted away all the complexities of different hardware. And it allowed programs to just interact with the hardware uniformly by simply reading and writing to these special files.
Wow.
That was a pretty clean design.
Yeah, it's amazing how that works. And then we also see kind of the first steps towards higher level programming, right?
Right.
With Douglas McElroy porting the TMG compiler to PDP-7 assembly.
Right.
And then Thomson was able to develop the first iteration of the B programming language.
Exactly.
It seems like at this point, like the pieces are starting to come together, right?
They are. You can see the fundamental building blocks of what would become Unix kind of emerging, driven by these practical needs and the ingenuity of these early pioneers.
So at this point, the system's functional, right? But it still doesn't have like a name.
Right.
I heard the initial name suggestion was kind of a playful nod to Multics, right?
Yeah. So the name Unix, short for Uniplexed Information and Computing Service, was suggested as this like clear pun on multiplex information and computer services.
I see.
And Brian Kernighan is credited with coining that name Unix in 1970. And he also notes that like the exact origin of the final spelling, Unix, is kind of uncertain, although Ritchie and McElroy also credit Kernighan.
So from an unnamed project to a project with like a memorable kind of pun-based name.
Right.
What really fueled the growth of this project?
So I think a really crucial factor here was the internal needs of Bell Labs itself. So the Computing Sciences Research Center wanted to use Unix on a larger machine than the PDP-7. And the patent department had this really urgent need for a word processor. So this led Thomson and Ritchie to add these text processing capabilities to Unix. And importantly, they were actually able to secure funding for a much more capable PDP-1145.
Okay. So we're talking about the PDP-11 era now.
Right.
It was kind of like a pivotal point, right?
Yeah, definitely.
That's where it got its official name.
Yeah.
And like all these early text processing tools were developed.
Absolutely. So they created this text formatter called ROF and a text editor as well. And these were initially written in PDP-11 assembly language.
Okay.
And Bell Labs immediately put this system to work processing patent applications. And that ROF program quickly evolved into TROF, which was a really groundbreaking development because it was the first electronic publishing program with full typesetting capabilities.
So something so fundamental to like digital publishing today has its origins in like these early Unix utilities.
Exactly.
So as more people started using the system, like obviously they needed some documentation, right? Like, how do I use this thing?
Yeah, and so they published the UNIX Programmer's Manual. It came out in November of 1971, and that introduced the now iconic man page format.
Okay.
These man pages provided this concise reference information.
Okay.
They also documented known issues and even like listed the authors of the programs.
Right.
So it fostered this very direct line of communication between like the users and the developers.
Yeah, that's very different from like, how software is developed and supported today, right?
Very much so.
So it seems like adoption within Bell Labs was really starting to accelerate at this point as like other departments started acquiring these PDP-11s.
Yeah, and they were actually choosing Unix over DEC's own operating systems.
Wow.
They saw the benefits and they went with Unix. And by the time they got to version 4, it was in widespread use internally. And they actually formed a Unix support group to kind of like formalize its distribution within Bell Labs, which was essential for its continued growth.
All right. So arguably, like the most significant development for Unix's long-term future was the decision to rewrite it in the C programming language in 1973.
Mm-hmm.
And that must have been like a huge undertaking at the time.
It was a huge undertaking because, at that time, the prevailing wisdom was that you needed assembly language for complex operating systems.
Right.
You needed it for the performance. And rewriting version 4 in C, which actually emerged as part of version 2.
Okay.
That directly challenged that assumption. In fact, McIlroy estimated that Thompson and Ritchie actually wrote and debugged something like 100,000 lines of code that year, just to emphasize how much work they were doing. And importantly, C was a higher level language than assembly.
Yeah.
And this meant that the code was no longer tied to the specific architecture of the PDP-11.
Wow, that's a staggering amount of work.
Yeah, it was. It was incredible.
And like this move to C, it had profound implications for portability, right?
Absolutely. While version 4 still had some PDP-11 dependent code in it, the C rewrite signaled that Unix could run on all sorts of different hardware architectures.
Got it.
In fact, the first actual port to another platform happened a few years later, in 1978. They ported it to the Interdata 832.
So Unix was gaining momentum within Bell Labs. The C rewrite kind of opened up the possibilities for a much broader future. So when did the wider computer science community kind of start to take notice?
So the formal introduction of Unix to the wider academic world actually came in 1973 at the Symposium on Operating Systems Principles.
Yeah.
Ritchie and Thompson presented this seminal paper on Unix.
Right.
And this generated a lot of interest, but there was a problem. There was this 1956 antitrust consent decree that prevented Bell System from engaging in businesses outside of common carrier communication services.
Okay, so they couldn't really sell it as a product, right?
Right.
But they could still share it.
Yeah. Exactly. So they started shipping the system. They would basically provide the tapes and discs for the cost of the media and shipping. And legend has it that Ken Thompson himself would often respond to requests by sending out these materials with a simple note, "Love, Ken."
That's amazing. That's like a really personal touch.
Right.
In the distribution of such a foundational technology.
It is.
And then in the mid-1970s, we see the release of version 5, which was mostly for educational institutions, and version 6, which was, for companies.
Yeah, so 1975 saw the release of version 6.
Yeah.
And that was the first version that was licensed to commercial entities.
Okay.
And while the commercial licenses were pretty expensive, around $20,000, version 6 actually became very popular and was widely used well into the early 1980s.
But even with those licenses, the terms were still pretty restrictive, right?
Very much so. So licensees, they received the source code,
Okay.
but it was provided as is with no guarantees and no support. And crucially, those machine-dependent parts of the kernel that were still written in PDP-11 assembly,
Okay.
those were also included in the distribution. And this led to the widespread, although technically license-violating, circulation of this thing called Lyon's Commentary on UNX 6th edition with source code,
Okay.
which actually became this invaluable educational resource.
It's almost like the lack of support, right?
Right.
Inadvertently fostered this strong user community that had to kind of figure things out on their own.
Exactly.
And I recall that the first meeting of Unix users actually took place in 1974.
Yeah.
Like this little gathering.
Yeah, it was just a small gathering of, a few dozen people.
Okay.
They met in New York. And this eventually evolved into the Usenix organization.
Okay.
And this user group played a really vital role because AT&T provided no official support.
Yeah. And the versioning system back then was kind of interesting, right? It was linked to the user manuals.
That's right.
Which is different from what we have today.
Very different. Yeah, versions were often identified by the addition of the user manual.
Okay.
The development process was more of a continuous evolution rather than these formal, discrete releases.
Got it.
And patches were often distributed informally, perhaps even without the full authorization of AT&T's legal department.
And then we see the introduction of pikes around this time.
Oh, yeah.
Which was a significant architectural advancement, right?
Absolutely. So the introduction of pipes allowed the output of one program to be fed directly as input to another program.
Okay.
And this might seem like a simple idea,
Right.
but this mechanism actually enabled this whole new paradigm of software composition.
Okay.
So it led to this much more modular approach to development, and it really accelerated the development cycle. So version 5, and particularly version 6, spawned like a whole bunch of different Unix variants,
Okay.
both within and outside Bell Labs. So, things like PWB UNIX, and there was IS-1, which was the first commercially available Unix.
Okay. And so despite, the growing portability due to C,
Right.
Unix was still primarily associated with DEC systems in the 1970s.
Initially, yes, but porting efforts were actively underway.
Okay.
And Bell Labs was dedicated to, making Unix more machine independent. So they ported it to platforms that were significantly different from the PDP-11,
Okay.
like the Interdata 832.
Okay.
We also saw ports to VM370 at Princeton and to the Interdata 732 by the University of Wollongong. There were even internal efforts at Bell Labs to port Unix to the Intel 8086.
Wow.
And even the UNIVAC 1100.
It seems like they were really laying the groundwork for widespread adoption.
Definitely.
And I also recall reading that ARPA, the Advanced Research Projects Agency, they actually documented the benefits of Unix in 1975.
Yeah, they released this RFC 681,
Okay.
which highlighted Unix's capabilities as a mini-host on the ARPA network.
Okay.
And then in 1978, they released UNIX32V for DEC's new VVAC system.
Okay.
Which was a significant step forward in performance and capability. And by this point, over 600 machines were actually running Unix in various forms. Well, it was really starting to spread.
Yeah. And then the decade concluded with the release of version 7 Unix in 1979, which is often considered like the last widely released research Unix version.
Yeah.
And I was struck by how few system calls it had, relative to like modern operating systems.
Yeah, that's a key observation. Version 7 had approximately 50 system calls.
Okay.
For comparison, later systems like 4.4 BSD, that had about 110.
Okay.
And modern Linux and FreeBSD, those have hundreds.
Okay.
So that really highlights how elegant and relatively simple the early Unix design was. And we also saw like a microprocessor port to the LSI-11 in 1978, and they were working on an Intel 8086 version, and we started seeing the first microcomputer versions of Unix and Unix-like systems emerging.
So the 1970s were really like a period of rapid evolution and expanding reach for Unix, right?
Exactly.
So then in the 1980s, we see a really significant shift with a move towards commercialization. And as the Wikipedia article notes, like an increase in fragmentation.
Right.
Bell Labs developed several internal Unix versions, right? And they even started marketing some of them externally.
Exactly. So you had, CB UNIX, PWB UNIXX.
Okay.
Those were used internally. And then they started promoting PWB UNIX 32V and V7 external. And they noticed that external usage really increased.
Okay.
So it went from over 800 systems in 1980 to more than 2,000 in 1981.
Okay.
And at the same time, research continued at Bell Labs. So you had versions 8, 9, and 10.
Okay.
But these were primarily for university use, and their impact was mainly through research papers. Interestingly, some of the tools from version 10 actually survived into the later Plan 9 system.
Okay. And then the research focus within Bell Labs kind of shifted entirely to Plan 9 and Inferno.
It did.
And that was kind of a new direction for the original Unix developers.
Exactly.
But in the meantime, they were licensing Unix, although there were still restrictions.
Right.
It was widespread, and it was relatively inexpensive.
Yeah.
And this led to thousands of users, both within AT&T and in academia. And as computer science graduates who were familiar with Unix started entering the commercial world, they started to see the demand for it in business settings really start to grow.
Right.
And so this idea that Unix could be like a universal operating system began to take hold.
Yeah, it was a very appealing concept.
Yeah. And like the Unix kernel at that time, it was pretty small, right?
Yeah, it was.
And it was also highly machine independent.
Yeah, so by 1983, the kernel was under 20,000 lines of C code.
Yeah.
And over 75% of it was actually machine independent.
Wow.
Which was pretty impressive for the time. And there was this whole variety of processors that could run Unix. And there were like 60 different vendors who were selling Unix systems.
Okay. So even big companies like DEC and IBM, right?
Yeah.
They started offering support for Unix as an alternative to their own like proprietary operating system.
Right.
And then, of course, we have this like microcomputer revolution of the early 80s.
Yeah.
And Unix starts entering the commercial market for microcomputers as well.
Right. So in 1980, Onyx Systems,
Okay.
they released a Zlog Z8000-based microcomputer running Unix.
Okay.
And then you had Microsoft announcing Xenix,
Okay.
which SCO later ported to the Intel 8086 processor in 1983.
So this is opening up a huge new market segment for Unix.
Exactly.
Yeah.
And then other companies followed suit.
Right.
So they were offering commercial Unix versions for their mini computers and workstations.
Okay.
And often these were based either on AT&T's System V or BSD.
And so BSD, like the Berkeley software distribution, becomes a really critical parallel development to all of this, right?
Yes.
And Bill Joy, a really key figure in BSD, went on to co-found Sun Microsystems and created Sun OS.
Exactly. So this is a really important part of the Unix story.
Oh, okay.
So while AT&T was moving towards this commercialization of Unix with System V, the researchers at Berkeley were continuing to develop BSD.
Yeah.
And they made all sorts of enhancements to BSD. Most notably, they added TCP/IP networking.
Okay, so that was huge, right?
It was a pivotal moment that shaped network communication for decades to come. Bill Joy's contributions to BSD were incredibly important.
Okay.
And his co-founding of Sun Microsystems in 1982 further solidified BSD's influence with Sun OS.
So meanwhile, AT&T made its own commercial intentions clear when they announced Unix System 3rd in 1981. And then they consolidated all their internal versions into this Unix System V Release 1.
Exactly. So System 3 was based on version 7 and PWB.
Okay.
And it introduced these relatively inexpensive binary sublicenses, which was a clear indication of their commercial aspirations for Unix. System V Release 1 that incorporated features from BSD, like the VS Editor and the Curses library, and supported their own 3B series computers. And they even established the Unix support group to actually provide, some level of commercial support.
But the real game changer for Unix in the 80s was the 1983 breakup of the Bell system.
Yeah.
That must have had a huge impact.
It was a watershed moment because the end of the 1956 consent decree really freed AT&T to fully enter the commercial Unix market with System V.
Okay.
But ironically, this newfound competition actually led to a lot of fragmentation and incompatibility.
Okay.
Which kind of hindered that free exchange of source code that had characterized the earlier development of Unix.
Okay.
It's also interesting to note that it was the same year that Richard Stallman founded the GNU project.
Right.
And that was partly motivated by these increasingly restrictive commercial licensing terms.
So we have AT&T pushing System V, and the Berkeley researchers are continuing to develop BSD as a more open alternative.
Right.
And this is what set the stage for what we now know as the Unix wars.
Yeah, absolutely. So because the commercial UNIX licenses were less appealing to academics, Berkeley just kept enhancing BSD, and they made some really significant contributions.
Okay.
So, you have the C shell with job control, but most importantly, they added the TCP/IP network code. And the network code from those BSD releases, like 4.1 CBSD all the way to 4.4 BSD Lite.
Okay.
That's the direct ancestor of much of the TCP/IP code that we still use today.
Wow.
Even in AT&T's System V and early versions of Windows, the Berkeley Sockets API, that emerged as this de facto standard for networking. And the Unix wars, they really highlight this tension, right, between open collaboration and commercial interests.
Yeah.
And they ultimately pave the way for more open alternatives.
It's ironic that while the commercial side was fragmenting, BSD was laying the groundwork for much of modern networking.
Yeah.
I also read that in the mid-'80s, there was this widespread expectation that Unix would become the industry standard for microcomputers.
Yeah, it was a common belief at the time because it was so portable, it had all these powerful features, and you had all these major companies supporting it.
Right.
But some people cautioned that its software library was relatively small compared to MS-DOS.
Okay.
And that might be a disadvantage.
Got it.
Microsoft, for their part, they envisioned Xenix as the multi-user successor to MS-DOS.
Okay.
But those Xenix systems were often very expensive.
Oh, yeah.
BYTE magazine even favorably compared the performance of an Alto system that ran Xenix to a DEC VAX.
Wow.
We also saw things like, the first Unix color windowing system in Unidix.
Okay.
So there were all these innovations happening.
Yeah, and amidst all of this commercial and technical activity, Thomson and Ritchie received the Turing Award in 1983 for their work on Unix.
A well-deserved recognition.
And by the mid-'80s, the perception of Unix was kind of starting to shift towards corporate data processing.
Right.
And you started to see mainframe versions becoming available.
Yeah.
But the install base was still relatively small, right?
Yeah, it was still relatively small. It was really the increasing power of microcomputers, especially those based on Intel's 80386 architecture in the late 80s,
Right.
that really caused Unix to explode in popularity for business applications.
Oh.
Yeah.
And they were competing with systems like OS/2. And you started to see, the annual Unix Expo trade show, which began in New York in 1984, kind of reflected this growing commercial interest. And we even saw the development of trusted versions of Unix for these high security applications during this period.
Okay. So this brings us to the late 1980s and the peak of the Unix wars, right?
Right.
You had all these different implementations. You had System V, BSD, Xenix, and various vendor-specific extensions.
Right.
So it must have been a really confusing time for users and developers.
It was really confusing. In fact, Paul Hennenkamp, he famously described it as this landscape of, quote, more or less competently executed combinations of System V and BSD.
Okay.
So customers were really demanding standardization at that point.
Okay.
So AT&T responded with the System V interface definition, or SVI.
Okay.
And this came out in 1985.
Okay.
And that aimed to create a standard, and it required conformance for the System V branding. At the same time, a bunch of European vendors got together and they formed the X-Open Consortium with the goal of creating an open system specification based on Unix and eventually aligning with SVI.
Okay.
The IE also joined in on these standardization efforts with the POSXX specification.
Right.
That came out in 1988. And that was meant to be this compromise API for both BSD and System V.